In this examples, the topics is limits involving radical. So let's do the first example. We try to do limit of square root of x minus 3 over x minus 9 as x approach 9. So like always, first if we plug in 9, we'll get square root of 9 minus 3 over x minus 9, which is 0 over 0. So in this case, every time we get a radical expression, what we do, we multiply the top and the bottom by the conjugate of the numerator. So in other words, this is going to be equal limit as x approach 9. This was square root of x minus 3 over x minus 9. So what we do, we multiply the top and the bottom by the conjugate of the numerator, which is square root of x plus 3. Now, why do we do that? The reason why we do that, so it's kind of like we rationalize the numerator. When we rationalize it, somehow we will get something like x minus 9 simplify, and we don't get a 0 over 0 anymore. So this is a limit. If we FOIL the top, we're gonna get, this is like a minus b times a plus b. So it's a square. So it's kind of like with square root of x squared, you're just gonna get the x minus 3 square is just a 9 divided by x minus 9 factor of square root of x plus 3. Well, square root of x plus 3 here as x approach 9. Now we can simplify x minus 9 over x minus 9. This will be equal limit as x approach 9 of 1 over square root of x plus 3. Now just plug in the 9 and you'll get 1 over square root of 9 plus 3, which is square root of 9 is 3, 3 plus 3 is 6, so it's 1 over 6. It's pretty easy. Now for example 2, same thing. If we plug a 2, we get 2 squared is 4 plus 5, 9, square root of 9, 3, 3 minus 3 is 0, over 2 minus 2 is 0, 0 over 0 is undetermined form. So what should we do? Multiply by the conjugate again. So the conjugate will be, so limit as x approach 2. The conjugate is square root of x squared plus 5 plus 3. And we do the same thing to the bottom, to the denominator. So multiply x minus 2 by square root of x squared plus 5 plus 3. And just like the first example, we always FOIL only the top. We don't FOIL the bottom. So x approach 2, if you FOIL the top, you're going to get a squared minus b squared. In other words, let me do it in, and we don't have enough, so we have enough space. Let me do it in 2 steps. X squared plus 5, we want to square this, minus 3 squared over x minus 2 square root of x squared plus 5 plus 3. Now this is equal limit as x approach 2. Now when you square the radical, you always get whatever's inside, which is x squared plus 5 minus 3 squared is just 9 over x minus 2 times, you don't FOIL the denominator, x square root of x squared plus 5 plus 3. Now this is equal limit. Plus 5 minus 9 is minus 4, x squared minus 4 over x minus 2 square root of x squared plus 5 plus 3. I mean, still, if we plug the 2, it's still going to be 0 over 0. So we need to somehow factor the top. If we factor the top, trying to get rid of the x minus 2. If we factor the top, we get limit of x minus 2, x plus 2. The denominator is going to still stay the same. Square root of x squared plus 5 plus 3 as x approach 2. Now simplify x minus 2 with x minus 2. This will be limit of x plus 2 over square root of x squared plus 5 plus 3 as x approach 2. From here, all we need to do now is just plug in. If you plug 2 into x, we get 2 plus 2 over 2 squared plus 5 square root plus 3, which is 4 over 4 plus 5 is 9, square root of 9 plus 3, which is 3 plus 3, 6, 4 over 6, which is 2 over 3. And that's it for these examples.